packing fraction of FCC, that is face centered cubic structure. So this is similar to simple cubic, but that means the 8 sides, the 8 atoms are common, along with 8 column, 8 atoms, each face having one more atom here. That means this is 1 2 3 4 4 faces having 4 atoms. These are 2 3 4 4 atoms are present here. This upper face, this is, and this red color atoms belongs to this front face and back side face. That means total 6 atoms are present. The value of these atoms are 1 by 8th part. That means at a diagonals we know very well these atoms are 1 by 8th part, but this atoms are the face centered atoms. Each atom gives half the atom. That means this face gives half part of the atom and this side face gives half. So the coordination number, here total 14 atoms are present here. 1 by 8th parts are 8, half parts are 6. Anyway, there are 14 are present here. The coordination number will be 12. If you choose any one atom in bulk, the nearest neighboring distance atoms are 12. Second one is nearest neighboring atoms. That is 2R. We have to find 2R. So again we have to consider a linear chain, or this is the actual picture here. 1 2 3 4 1 by 8th part of atoms. This is 50%. This each face contains one more atom here. This is the actual diagram, and we have to draw one more diagram to calculate. That means no need to draw the complete diagram. We have to consider a face. That is enough for us for calculation purpose. You consider a face. You have to find a linear chain of atoms. That means 1 2 3 1 2 3, any 3 atoms, the linear atoms. Here I consider one face of the crystal, then this is the edge, this is center of the face, and this is at edge. This is 2R, this is R, and this is R. Give names. This is A, B, C. ABC. This is edges. These are the crystal edges. This is A. This also A. Okay. Now we have to find this 2R. At this position, what will be the nearest neighboring atoms distance? Consider triangle ABC. By knowing Pythagoras theorem, we can easily calculate this value. ABC I have to consider, and consider Pythagoras theorem. That means hypotenuse square is equal to side square plus side square. That means AC square is equal to AB square plus BC square. That is equal to AB means A square, BC means A square. That is equal to 2A square. This is AC square is equal to. This is very simple calculation. But from diagram, this answer with respect to the crystal edges, it means A, B and C belongs to this square. Now we have to consider these spheres. Now we have to calculate the value, AC value, with respect to the spheres. That means atoms. From diagram, R with respect to atoms. We can write like anything. AC is equal to R plus 2R plus R, that is 4R. Now put, this is 1, this is 2. Put equation 2 in equation 1, means 4R square is equal to 2A square. That means 4R is equal to 2A square. 4R means 4 into 4R, square means 4R is 16R equal to 2R square, 16R square. This is 2A square. Then remove root. This will be 4R root 2 into A. Now apply root to this equation. Then we have to find 2R, that is 2 into 2R. 2 into 2R is equal to 2 into 2R is equal to root 2 into A. That means 2R is equal to root 2 by 2 into A. Here we can write 2 as first root 2 by 2 into A by root 2 into root 2. That means 2 can be written as root 2 into root 2, and 1 root 2 will be cancelled. That will be 2R is equal to A by root 2. Now write this equation here. That means 2R is equal to A by root 2. Now point 3, atomic radius is equal to R is equal to A by this 2 root 2. Fourth one, lattice constant. A is equal to 2 root 2 R. This is lattice constant. The fifth one is the effective number of atoms is equal to, effective number of atoms means here you have to consider 1 by 8th part of each atom. That means 1 by 8th parts are 8, and this is half parts are 6. That means 1 by 8 into 8 plus 1 by 2 into 6, then that is equal to 1 plus 3 is equal to 4 number of atoms are present in this cell. Now I have to find the packing fraction of this FCC. This is packing fraction. The last point is the volume of the atoms in the unit cell V divided by the volume of the unit cell capital V. Now we know the volume of the atoms in the unit cell. That means 4 number of atoms are there, and 4 by 3 pi r cube gives the volume of each atom, that is equal to 16 by 3 pi r cube. The volume of the unit cell is common for all, that is equal to A cube. We know A means 2 root 2 into R whole cube. So let us substitute P is equal to V by V and calculate. P is equal to 16 pi r cube by 3 divided by 2 root 2 r cube, 2 root 2 r whole cube. This will be 16 pi r cube by 3 into 2 root 2 r whole cube. Okay. 16 16 16 pi r cube by 3 into 2 cube means 8, that is 2 root 2 r cube. R cube gets cancelled, that is 16 pi by 3 into 8 into 2 means 16 root 2. 16 gets cancelled, the remaining will be pi by 3 root 2, that is pf. Yes. pf, the packing fraction, then that is equal to 0.74. by calculating this, that is equal to 3.14 divided by 3 root 2. By calculating this is 70.74 or 74%. The packing fraction will be. That means in this unit cell, this particular unit cell, the 74% of space was occupied by these atoms. The 74% of space was occupied by atoms. The remaining will be the remaining 26% of space was void. Void means empty. Empty means free space. So for simple cubic, that is 52%, for BCC 68%, and FCC 74% of occupation of atoms. So when compared to all atoms, the more density is having for FCC, very less density is having for simple cubic. So these are the packing fractions of these three types of crystals. Thank you. Of course, this is very important for examinations for all BTech first year and BSc also. Thank you.